Hello, children. Today's lesson is for March 18th, and it's about the sum and difference formula for sine and cosine. Today's lesson is brought to you by the unit circle we all love. Okay, back to work. Now you can see here that the sine and cosine have formulas for sum and difference, and it's not as easy as it looks. You can't just say I'm going to distribute the sine or distribute the cosine. The calculations don't seem to work out just right, so a proof of these does exist online. If you're interested, you can look those up. But for now, I'm going to expect you to trust me and take a look at these. Even though they look daunting, there's some kind of pattern in here. Notice that the U's and the V's and the U's and the V's. So the U's and V's never travel. They don't change location. But for the sine, you'll notice that the sines are on the outside and the cosines are on the inside. And for the cosine, it just goes double cosine, double sine. And for double cosine and double sine. And just watch your signs. As far as cosine, they seem to be opposite. And for the minus here is a plus. And for sine, they just seem to match. So you'll get used to these the more you start to apply them. Now, applying these would be for a question like exercise 1. So we're not going to waste too much time. And we're going to say cosine of 75. We're going to figure this out without a calculator. We're going to find its exact value. And cosine of 75 is not on the unit circle, but we can take that 75 and we can break that up into two different angles that we do know, like 45 degrees and 30 degrees. In this case, it kind of matches this scenario, and therefore the 45 would count as the U and the 30 would count as the V. Therefore, we would be trying to set this up as a cosine of 45 cosine 30 minus sine 45 sine 30. And now we just, again, use our unit circle and find all those sines and cosines. And I know that this picture is embedded deep inside of your brain, so you don't need to keep looking at this. But I will help us out here. The cosine of 45 is just radical 2 over 2. Cosine of 30 is radical 3 over 2. And the sine of 45 is radical 2 over 2 times a half. And when you're multiplying fractions, it's top times top and bottom times bottom. So radical 2 times radical 3, we're going to go radical 6. The denominator is 4. And minus square root of 2 over 4. We have common denominator, so that's beautiful. So we may as well put it together as a single fraction over 4. And the square root of 6 minus square root of 2. I know you feel like you should do something with that, but fight the urge, just circle it. That is the exact value. So when they say exact value, that's what they would like from you. Okay. Now, okay, that was visible. All right. Move down to exercise 2, please. All right. And in this case, we're kind of going the other way. We're going backwards. They gave you some kind of sine formula for a difference, and therefore 7 pi 6 would count as your U, and 3 pi 4 would count as your V. And so the setup for this should be sine of U cosine of V minus cosine U sine of V. And I'm getting that from the top of the sheet, but I'm trying not to move it around too much, so you can hit pause and check up there. All right, so let's fill in everything. Let's put the 7 pi 6 then. And the 3 pi 4ths then. And then we just have to be, again, very careful with our unit circle. Remember, pi 6 is a version of 30 degrees, and if you have 7 sections of 30 degrees, that's all the way around to 210 degrees in quadrant 3. So the sine of that is -1/2. And the cosine of 3 pi 4ths, that's 135 degrees, that is negative radical 2 over 2. 7 pi 6 again, the cosine, negative radical 3 over 2. Put negative in there. And cosine of 3 pi 4ths is radical 2 over 2. And the cosine of 3 pi 4ths is negative. I copied that wrong, didn't I? Yes, I did. I meant to write sine. All right. There is my first mistake. I'm sure that somebody out there named Jacob is really, really upset about that. But I'm fixing it. Let's make that a sine. All right, everything else matches. Sine, cosine, cosine, sine. All right, sorry about that, guys. So that is a positive radical 2 over 2. All right, top times top, bottom times bottom. Over here, we're getting a positive radical 2 over 4 minus, and then this is a negative radical 6 over 4. And combining to a single fraction over 4. Radical 2, and that's going to be plus radical 6. And again, that's exact. So we're not going to mess with it. We're just going to move on to the next question. All right, so bottom of the page, example 3. All right, it's visible. Okay. So in this case, we're working in reverse, and we're going to simplify this expression and find an exact value. So if you kind of look at this as above, and of course, you remember the u's and the v's don't travel. So these are u's and these are v's. Therefore, the one that matches it looks like a sine of u minus v. And if you place the 70 here and the 10 there, you'll have something familiar. 70 minus 10 is sine of 60. All right, so that's what they're trying to get us to calculate in disguise. And the sine of 60 is your favorite number. Square root of 3 over 2. And that's that. So let's turn this page over and finish the back side. All right, so here's a simplifying expression, and what you're going to do basically is put your thumb over top of that for now and use the rule on the front to simplify that. And when you're done, we're going to do the same thing to this. It's going to turn into a giant mess, but we'll still figure it out. All right, so let's treat this as u and treat the x as v. Let's treat the pi halves as u and the x as v. So all of my attention right now is right here, and execute the difference formula for cosine. So that would be cosine of pi over 2, and then times the cosine of x, plus the sine of pi over 2 times the sine of x. Okay, So then this plus sign is going to be placed right here. So just so you see where that's coming from. And now we're going to execute the sum rule for cosine. So we are going to say cosine of pi halves cosine of x minus sine of pi halves sine of x. And then we're just going to examine each one of these pieces. This first piece says cosine of pi halves. Remember, that's 90 degrees. The cosine, or x value there, is 0. If this is 0, 0 times anything makes this entire term become 0. So this doesn't exist anymore. Sine of pi halves, that's 90, so that's the y value. That is going to be 1. 1 times sine of x is just sine of x. So this piece, sine of x. Let's see, this piece here has cosine of pi halves. Again, same trick. That's a 0. 0 times who cares is 0. Gone. All right, and same thing. That piece right there is a 1. So 1 times that is still negative sine x. And we have a subtraction. Therefore, we have a 0 for our final answer. And that's all there is to that simplification. All right. Exercise 5. One of your favorites, verifications. Don't seem to be going away. We're going to work on one side and make it look like the other. So in this case, this left side looks like the more difficult side, and basically what you learned today. So we're going to fiddle with this and make it look like that. So we are going to treat this as u and treat the x as v. And therefore, we are going to be saying the sine of 3 pi halves times the cosine of x minus the cosine of 3 pi halves times the sine of x. And just do the simplifying. The sine of 3 pi halves, that is 270 degrees. And the y value there is negative 1. So we're saying this is negative cosine of x. The cosine of 3 pi halves, or 270, is going to be 0 again. So you get this entire section to multiply out to be 0, and you don't need to see it. So I have negative cosine x, which is the right-hand side. So that is a very, very straightforward and quick identity. All right, so we'll finish with a little bit more challenge with exercise 5, exercise 6, sorry. So it says we're going to sketch these triangles in the proper quadrants. We're going to follow all of this given information. The sine of some angle u happens to be 4/5, and that angle happens to be in quadrant 1, or between 0 and pi half. So just draw a triangle which happens in quadrant 1. And if this is the angle u, and the sine was 4/5, which means the opposite is 4 and the hypotenuse must have been 5. And since this is a 90-degree triangle, you may recognize this as a Pythagorean triple. So therefore this side must be, so that's a 3, 4, 5 triangle. All right, so then they give us more information. Another angle, which is v, which happens from pi halves to pi, so then we're talking quadrant 2. I'm going to draw a completely separate picture here and get in quadrant 2. Okay, drop the 90, and this is angle v. So the sine is 5/13, so that means opposite over hypotenuse, 5/13. And you might recognize this one as a triple as well, 5, 12, 13. So if you didn't recognize them as a triple, just use Pythagorean theorem. All right, fine. And it says to figure out what cosine of u plus v is, well, from the front of the sheet. Cosine of u, hold on, bear with me. Cosine of u plus v, well, that's supposed to be cosine of u cosine of v minus sine u times sine v. So we basically got two different things that are going on here. This is for angle u, and we know for a fact, I'm going to write this down, that the sine of u is 4/5. Therefore, the cosine of angle u must be adjacent over hypotenuse, 3/5. Okay, so do the same thing over here. The cosine, or excuse me, the sine was given of v to be 5/13, and then the cosine of v, you gotta be careful on this one because you are in quadrant 2. So don't just put down adjacent, which is 12 over hypotenuse 13. Make sure that you are negative 12 over 13. All right, so basically now you just have to plug all of these values in. So the cosine of u is here, 3/5. The cosine of v, well, that's over here, negative 12/13. Minus the sine of u, which is 4/5. Times the sine of v, which is here, which is 5/13. All right, top times top, bottom times bottom. I'm looking at negative 36 over 65 minus 20 over 65. Common denominator of 65. Numerators go together and make negative 56. Okay. All right, that's all I have for today's lesson. So you guys are on to trying your homework, which is here in the book, page 373, 2 through 24 even, and try to work out number 28, okay? If you guys have issues, just send me an email that says which ones you want to be worked out, and I will work those out and try to have those posted for you. All right, thanks again, and have a good day. All right, bye.